In this class, we discuss about an important limit of JEE main and advanced level. And the limit is limit x tends to 0. This is 1 to the power x plus 2 to the power x plus and so on plus n to the power x by n. This is equal to 1 by x is equal to 4 options are given here. We have to choose the correct option. Now we clearly see that this limit is of the form limit x tends to a fx to the power gx, right? Here we get two different conditions. If we see that limit x tends to a fx, this is greater than 0, then we easily write this limit as limit x tends to a fx to the power limit x tends to a gx. The second case, if limit x tends to a fx, this is equal to 1, and limit x tends to a gx, this is equal to infinity, then we write this limit is equal to limit x tends to a e to the power g of x into fx minus 1. But why we can write this limit is equal to this type? And the reason behind it, we write this limit as by simply taking exponential function. This is e to the power g of x into log of fx, right? We can write this, and we write fx, this is equal to 1 plus fx minus 1. And now expanding this series, because the expansion of log 1 plus x, this is x plus x square by 2 and so on, where mod x less than infinity. Okay, we use this formula here, and this is given by limit x tends to a e to the power g of x into, this is the x means fx minus 1, this is here x because this is 1 plus x, plus this is fx minus 1 whole square by 2 and so on. Okay, now since limit x tends to a fx, this is equal to 1, then fx, limit of fx, this is equal to 1. So this type of term, square, cube and so on, are very small. So we neglect all the term after the first term. Then we get the limit as limit x tends to a e to the power g of x into fx minus 1. Okay, and this is the formula. And here we clear that this is the function fx, and this is tends to, clearly if we put x equal to 0 here, so we get 1 plus 1 plus 1 plus 1, this is n by n, this is equal to 1. And if we take the limit 1 by x as x tends to 0, then we get this is infinity. So this is 1 to the power infinity form, so we use the second form. Okay, and this is given by limit x tends to 0, and this is given by e to the power 1 by x, this is fx into gx minus 1, and this is 1 to the power x plus 2 to the power x to n to the power x by n minus 1. Okay, and this is given by limit x tends to 0 e to the power 1 by x into 1 to the power x minus 1 plus 2 to the power x minus 1 plus n to the power x minus 1 by, we write here x, x and x, and here we write n. Okay, because if we take LCM of n and this is given by n, and we write n outside of the bracket, and we write x in each denominator. Okay, and we know the formula of this limit, and we get the formula as limit x tends to 0 e to the power 1 by n, and this is log 1, this is log 2, and so on. This is log n, right? And we get limit x tends to, sorry, here we cannot write the limit because we already used the formula and taking the limit x tends to 0, and this is 1 by n e to the power 1 by n and into log of 1 into 2 into n. So e to the power 1 by n into log of n factorial, that is e to the power log of n factorial to the power 1 by n. N factorial to the power 1 by n. So we get the limit n factorial to the power 1 by n. Okay, and the correct option is n factorial to the power 1 by n. I changed the option because there be a wrong option. Okay, this is the value of this limit, and this is very important type of limit.